In traditional finance, every transaction requires a web of intermediaries: brokers, clearinghouses, custodians, transfer agents, and legal counterparties. Each layer adds cost, latency, and counterparty risk. Smart contracts eliminate this entire infrastructure layer, replacing trusted intermediaries with self-executing code that runs exactly as programmed, without the possibility of fraud, downtime, or human error. The concept, formalized by cryptographer Nick Szabo in 1994, found its first truly scalable implementation on Ethereum. A smart contract is simply a program deployed to the Ethereum blockchain, immutable, transparent, and autonomous. When predetermined conditions are met, the contract executes automatically, transferring assets, issuing tokens, or triggering downstream contracts without any human intervention. For institutions accustomed to T+2 settlement, legal disputes, and operational overhead, the implications are profound. Smart contracts can settle trades instantly, manage collateral dynamically, and enforce contractual obligations algorithmically. The question is not whether this technology will reshape financial infrastructure, it already is, but how institutions should evaluate and interact with it responsibly. The execution model of smart contracts is fundamentally different from traditional software. When you interact with a smart contract, your transaction is broadcast to every Ethereum node in the network. Each validator independently executes the same code and arrives at the same result, a process that provides Byzantine fault tolerance without requiring trust in any single node operator. The Ethereum Virtual Machine, or EVM, is the sandboxed execution environment that runs all smart contract code. Every validator runs an identical EVM, ensuring that a contract deployed today will execute identically in 10 years on whatever hardware validators are using then. This determinism is critical for financial applications where ambiguity in execution is unacceptable. The immutability of deployed contracts is both the source of their trustlessness and a significant operational risk. Unlike traditional software that can be patched when bugs are discovered, a deployed smart contract cannot be altered. Sophisticated protocols address this through upgradable proxy patterns, but these introduce their own governance risks. For institutions, this means that smart contract code must be audited to a far higher standard than traditional financial software before capital is committed. The institutional use cases for smart contracts are moving from theoretical to operational. BlackRock's Bidal Fund, a tokenized money market fund on Ethereum, demonstrates that the world's largest asset manager sees smart contract infrastructure as viable for regulated financial products. The fund uses smart contracts to manage share issuance, redemption, and yield distribution with a level of transparency and automation that legacy fund administration cannot match. In derivatives, smart contracts enable atomic settlement of complex instruments. A credit default swap executed via smart contract can automatically trigger payment upon verified Oracle confirmation of a credit event, eliminating the legal disputes and settlement delays that plagued OTC derivatives in 2008. JP Morgan's Onyx platform and Goldman Sachs's tokenized bond issuances are early evidence that TradFi institutions see genuine efficiency gains in on-chain settlement infrastructure. For institutions deploying capital into smart contract-based protocols, the critical distinction is between audited, battle-tested contracts with years of on-chain track records and newer protocols with unproven code. The former can be evaluated with a risk framework analogous to counterparty credit assessment. The latter carry binary smart contract risk that is categorically different from any risk category in traditional finance. The flow from user intent to on-chain settlement in a smart contract system is radically more direct than the equivalent process in traditional finance. A user signing a transaction interacts directly with the contract's logic. There is no broker to route the order, no clearinghouse to guarantee settlement, no custodian to hold the resulting position. The contract itself performs all of these functions simultaneously and atomically. This directness is both the technology's greatest strength and its primary risk vector. In traditional finance, the multiple intermediaries that add cost and latency also provide multiple checkpoints where fraudulent or erroneous transactions can be caught and reversed. In a smart contract system, a transaction that passes the validation rules of the code is irrevocable, even if the user was defrauded, hacked, or made an error. For institutions, this means that pre-transaction controls and code verification become the primary risk management tools. The due diligence process for a smart contract must include independent security audits, formal verification where applicable, review of upgrade mechanisms, and a clear understanding of what Oracle data the contract relies upon, because all of these represent potential vectors for loss. Smart contract risk is not a single risk type. It is a family of distinct vulnerabilities that require different mitigation approaches. Code vulnerability risk is the most publicized. The 0.8 billion Ronin bridge hack, the 0.0 million Poly network exploit, and dozens of smaller incidents demonstrate that even audited code can contain critical vulnerabilities. The correct institutional response is not to treat audits as a certification of safety, but as a necessary but insufficient component of due diligence. Oracle risk is more subtle and arguably more dangerous precisely because it is less understood. Smart contracts are deterministic within their own execution environment, but they cannot natively access real-world data. They rely on Oracle networks, typically Chainlink or protocol-specific solutions, to feed price data, interest rates, and other off-chain information. If this data is manipulated, the contract executes correctly according to its code but produces economically incorrect results. Flash loan attacks that temporarily distort Oracle prices have caused hundreds of millions in losses. Institutions should treat the smart contract audit report as equivalent to a legal opinion. Necessary, meaningful, but not a guarantee. The institutions that have emerged from DeFi with intact capital are those that maintained conservative position limits, diversified across auditors, monitored on-chain activity continuously, and had clear exit procedures when anomalous behavior was detected. The legal status of smart contracts remains one of the most actively litigated questions in financial law. Courts in multiple jurisdictions have begun to grapple with whether a smart contract constitutes a legally binding agreement, what recourse exists when code execution diverges from the party's economic intent, and who bears liability when an audit fails to catch a critical vulnerability. The emerging consensus among institutional legal teams is that smart contracts must be backed by traditional legal agreements that document the party's intent and provide a dispute resolution mechanism for scenarios the code cannot handle. The contract code handles the mechanical execution. The legal agreement handles the edge cases, regulatory compliance, and liability allocation that cannot be reduced to deterministic code. This dual-layer approach, code plus legal wrapper, is increasingly the standard for institutional DeFi participation. BlackRock's BIDL, JP Morgan's Onyx, and Franklin Templeton's tokenized fund products all operate with explicit legal documentation alongside their on-chain smart contract infrastructure. This is not a limitation of the technology. It is the correct architecture for institutional capital operating in a regulated environment. Smart contracts represent one of the most significant innovations in financial infrastructure since electronic trading. The ability to encode complex financial agreements in self-executing code, eliminating counterparty risk, settlement latency, and operational overhead simultaneously, has implications that extend far beyond cryptocurrency speculation. For institutional investors, the key insight is that smart contract technology is not a feature of DeFi speculation. It is infrastructure that is already being adopted by the largest institutions in traditional finance. The question is not whether to engage with smart contract-based financial products, but how to evaluate, size, and risk manage that exposure with appropriate sophistication. The framework is clear. Treat smart contract protocols as you would a new counterparty, with rigorous due diligence, position limits, continuous monitoring, and explicit exit criteria. The code may be immutable, but your exposure to it need not be. Institutions that build this capability now will have a structural advantage as on-chain settlement infrastructure continues its convergence with traditional financial markets.